Good evening. How are yous? Captain Grumpy Bandit reporting. Guys, we are flying over to Orlando, Florida, where we've set up another HBO or a base. So itinerary today, we're over here in Lubbock, Preston, in Texas. We're heading over to Orlando International Airport. Hope you can join us for the flight. And we're going to go to Orlando, and then we've got to fly up to New York from there. And we've got to do it tonight because I have to do a reference flight. Anyway, without further ado, let's get in there. Let me just check my sound settings here for you guys. Yeah, we're all good there. Alright, let's get this party started. So we got a passenger flight, guys. We're taking a bunch of party animals over to bloody Disney World. I think to go into a concert. Let's have a look. We've got little bit of gear. Public address. So we've got a PA system. Oh, jeez, we've got some refugees as well. Bloody 300 of the buggers. We've got 3 festival attendees and 52 technicians. Holy cow, should be the other way around. Must be going to set up a concert, but anyway. Okay, let's get their booties over there. Let's get this thing started. It's very early in the morning here in Texas. Okay, we're going to get the batteries on, get that APU kicking.
Lubbock clearance delivery American 53 heavy IFR to Orlando ready to copy.
American 53 heavy is cleared to Orlando Airport as filed. Take off runway 35 left climb and maintain 15,000 feet. Departure frequency is 119er decimal niner squawk tree 624.
American 53 heavy cleared to Orlando.
That's our that's a generator at the back, guys. That's an APU. See that little hole? That's the exhaust for the APU. It's like a separate engine. Oh, a nice little 320 next to us. Sexy. Sexy.
Lubbock ground American 53 heavy requesting pushback.
No, we don't want a bloody pushback, guys. Good. I didn't ask for pushback. Thank you, darling. Alright, let's get our APU on. Let's get our generators. Alright, we're going to get our fuel pumps going. And we'll get our air bleed going. Get our beacon light on immediately. And let's get the party started. Start these engines up. Alright. Engine time.
Lubbock ground American 53 heavy with Yankee ready to taxi IFR. American 53 heavy taxi to and hold short of runway 35 left by taxiway Lima Delta Bravo. Contact tower on 120 decimal 518.
Engine spooling up. There, beautiful sound.
Taxi and hold short runway 35 left by taxiway Lima Delta Bravo American 53 heavy. Taxi to and hold short runway 35 left using taxiway Lima Delta Bravo
Nice of
American
them.
53 heavy.
Getting there. Beautiful. Alright, we got our passengers actually already loaded on board here. So we'll get our hostess to work here.
Hello everyone. Captain and the entire crew would like to welcome you aboard on this aircraft. We are also getting ready for departure, which I would like to ask you to fasten your seatbelts. Make sure your seats are in the upright position, tray tables are folded. Make sure your cabin carry-on items are properly stored. Once again, we would like to remind you that this is a non-smoking flight. So please refrain from smoking. Also, mobile systems should be set to airplane mode. Your cabin crew is here for your safety and comfort, and thank you for flying with us. Ladies and gentlemen, on behalf of the captain and the entire crew, welcome aboard. Now we request your full attention as the flight attendants demonstrate the safety features of this aircraft. When the seat belt sign illuminates, you must fasten your seat belt. Insert the metal fittings one into the other, and tighten by pulling on the loose end of the strap. To release your seat belt, lift the upper portion of the buckle. We suggest that you keep your seat belt fastened throughout the flight, as we may experience turbulence. There are several emergency exits on this aircraft. Please take a few moments now to locate your nearest exit. In some cases, your nearest exit may be behind you. If we need to evacuate the aircraft, floor-level lighting will guide you towards the exit. Doors can be opened by moving the handle in the direction of the arrow. Each door is equipped with an inflatable slide which may also be detached and used as a life raft. Oxygen and the air pressure are always being monitored. In the event of a decompression, an oxygen mask will automatically appear in front of you. To start the flow of oxygen, pull the mask towards you. Place it firmly over your nose and mouth, secure the elastic band behind your head, and breathe normally. Although the bag does not inflate, oxygen is flowing to the mask. If you are traveling with a child or someone who requires assistance, secure your mask on first, and then assist the other person. Keep your mask on until a uniformed crew member advises you to remove it. In the event of an emergency, please assume the bracing position. Lean forward with your hands on top of your head and your elbows against your thighs. Ensure your feet are flat on the floor. A life vest is located in a pouch under your seat or between the armrests. When instructed to do so, open the plastic pouch and remove the vest. Slip it over your head. Pass the straps around your waist and adjust at the front. To inflate the vest, pull firmly on the red cord, only when leaving the aircraft. If you need to refill the vest, blow into the mouthpieces. Use the whistle and light to attract attention. Also, your seat bottom cushion can be used as a flotation device. Pull the cushion from the seat, slip your arms into the straps, and hug the cushion to your chest. At this time, your portable electronic devices must be set to airplane mode until an announcement is made upon arrival. We remind you that this is a non-smoking flight. Tampering with, disabling, or destroying the smoke detectors located in the lavatories is prohibited by law. You will find this and all the other safety information in the card located in the seat pocket in front of you. We strongly suggest you read it before takeoff. If you have any questions, please don't hesitate to ask one of our crew members. We wish you all an enjoyable flight.
OnAir started tracking automatically. Your flight will be monitored until you land and shut down the engines.
Beautiful morning in Texas here. Look at the weather, chat. Absolute gorgeous day. Morning, ladies and gentlemen. It's Capitano speaking. We're going to get you over to Orlando this morning.
Lubbock Tower, American 53 Heavy ready for ISR departure runway 35 left. American 53 Heavy altimeter 29.9, full wind 26410. Cleared for takeoff runway 35 left. Cleared for takeoff runway 35 left American 53 Heavy.
Yeah, we're going to get you over to Orlando, Florida. The weather's absolutely beautiful over there. It's clear at the moment. It's nearly 14 degrees Celsius. That's 57 degrees Fahrenheit. Absolutely beautiful. We aren't going to have any problems. We're not foreseeing any turbulence or anything. So without further ado, buckle up and we'll touch base with you when we're ready to start making our way down for our landing. So have a good flight. Get ready for landing, crew. Ready for takeoff, I should say. Too many coffees this morning. Okay, we're cleared. Final check. Strobe on. Co-pilot forgot to set our V speeds, but we're good. Rotate. There we go. We've got that problem with our
Airborne time logged.
gear up. Positive climb.
American 53 Heavy contact Lubbock departure on 119.9. Good day. 119.9 for American November 73 Alpha November Heavy. Lubbock departure American November 723 Alpha November Heavy is at 4,700 feet, climbing 15,000 feet.
American November 723 Alpha November Heavy Lubbock departure altimeter 29.
Oh, what a beautiful sunset. Sunrise this morning. Aren't we blessed? Flaps up. Flaps up to 5. Flaps up to 1. And flaps up fully. I'll get on our line here. Catch you later, Texas. See you next time. Look at the weather. It's just beautiful. The oil refineries back there.
American November 723 Alpha November Heavy contact Fort Worth Center on 132.6. Good day.
Beautiful plane.
Passing 10,700 feet, climbing 15,000 feet. American November 723 Alpha November, heavy 4-port center altimeter, 29.4 continue to 60 as planned.
Okay. AP on. Let's head straight up to 37. Okay. Great. And LNAV on. See if she'll line up. Yep, she's lining up. Let's get our Fletch on. Our auto throttle.
American November 723 Alpha November, heavy climb, and maintain flight level 250. Climb and maintain flight level
Okay, just run
250.
some checks here.
American November
Disarm
723 Alpha
speed
November,
brake.
heavy.
Turn our APU off. Check our anti-ice is all off. Window anti-ice off. Taxi's off. Strobe on. Logo nav beacon on. We're over 10. Let's kill our landing lights. Beautiful. I'm going to pull my blinds over here. How's it going back there in business, you guys? It's where we got ya.
North Center, American November 723 Alpha November, heavy, requesting vector to next waypoint.
I love flying in the morning.
American November 723 Alpha November, heavy.
The lighting is absolutely beautiful on this game.
070.
Alright, we're on our way.
Turning and following heading
On our way to Florida.
November 723 Alpha November, heavy.
Just off to LLO, and we're going to bank left. Make our way towards the Gulf of Mexico.
Ladies and gentlemen, the captain has turned off the fasten seat belt sign. For your continued safety, we would like you to keep your seat belt fastened at all times while seated. Ladies and gentlemen, we will shortly be passing through with food and drink. Please check the magazine in front of you for the full menu as well as our duty-free offers. Thank you.
10 subs today, guys. It's pretty good. Pretty good. Keep that up. Just keep crawling up. Only thing is the old bloody... It's a bit hard to get on the radar. Sometimes if you don't fill out your stream information, it can affect your algorithm. The algorithm. What am I doing here? I'm gonna see what's going on. Why we're not coming up. And on our way there, I'm gonna have to do some updates. I need to. Okay, why are we not showing up here? We're live. It's public. Oh, maybe you need a viewer. Hey, Modest, how are you, buddy? When did you leave that? 9 o'clock. Oh, you just popped in. How are you, brother? Modest? Hey, Modest, how are you, buddy? Take a seat, my friend. Business class for you boys. Sorry, first class. I know it looks like business, but it's first class. Alright. The girls will look after you, mate. Greta, could you bring a triple scotch of the best down to seat number 5 for Mr. Modest, please? And when we get to our ceiling height, guys, we'll be running some in-house entertainment. Yeah, nothing but the best for the boys.
November 723 Alpha November Heavy climb and maintain flight level 370.
Climb and maintain flight level 370 American November 723 Alpha November Heavy.
And then this pilot's going to go back there and have some dinner. It's that time of night. Actually, it's past my dinner. I got caught up watching a bit of Twitch and then got the old stream set up. It's amazing. The live.
November 723 Alpha November Heavy contact Fort Worth Center on 126.15. Good day.
What we're going to do with ATC is we're going to shut them up. Hold on.
Fort Worth Center American November 723 Alpha November Heavy is at flight level 335 climbing flight level 370.
American November 723 Alpha November Heavy Fort Worth Center continue to 15 as planned.
Yeah, setting it up is a bit of a bloody hassle, but once you get it down, your system, it becomes a bit easier, but it's so much better than pre-recording. Like, if I had to upload these files, it would be a major pain in the butt. Okay, we're nearly there. Nearly there, boys. There goes the door. Alright, I'm going to turn the noise cancellers on here for you guys, and we'll turn off the ATC voices. Give you guys a piece of quiet on the way there. Let's check our local time here. Local time is 8 o'clock in the morning. We're just about at our ceiling height here. I'll run these ads. I'll turn these ads down for your in-flight entertainment. We've got a history doco on the 777, so for you guys who don't know, we're going to give you a history lesson on the way there. But we will save you the ads. Okay, we're nearly there. We can start speeding up. We're going to go to Mach 86. Oh, we're coming up to LLO, and then we're going to start lining up with the Gulf of Mexico. I'll give you guys a little insight onto our flight plan today. So you can see we are heading down towards just north of Austin, Texas. We'll go just a smidge over Houston, and then we're going to probably come around New Orleans and then down towards Tampa.
Complex machines ever built. It would take 10,000 people and nearly 5 years to build it. It would cost an estimated $5 billion. Success was anything but certain. The plane would contain more than 4 million parts supplied by contractors around the world. But would they arrive on time?
Miss your first commitment, and then things start to go wrong.
And would they work?
From a technical point of view, I would not put this back on the airplane if I had a choice.
Nothing could be left to chance. 154. This would be the most tested airliner in aviation history. Eventually, lives would be at stake.
There's an apprehension anytime you change technology.
To make it all work, the company would reinvent itself from the inside out. And all of this would have to happen at a time when the world's airline industry was in recession. If the 777 were to fail, the company's future was at risk. Success would keep Boeing ahead of the competition for decades to come. This plane would be built to set a new standard for commercial aviation. This is the story of the building of a 21st century jet.
I'm sorry.
300 people are boarding a flight from London to Washington, D.C. It's actually an inaugural flight, although most of these people didn't know it when they bought their tickets.
This just happened to be the day we needed to go back to Washington, and the secretary made the flight. I don't think she knew it was the inaugural flight, so just pure coincidence.
This is the first commercial flight by United Airlines of a brand new airliner, the Boeing 777. The chances are that anyone who travels to Europe or Asia will sooner or later fly in the 777, as this plane replaces the older 747s on many overseas flights. It's Boeing's 7th new airliner, and the company has staked its future on it. In economic hard times for the airline industry, Boeing hopes the 777 will keep the company prosperous well into the 21st century.
To put it on, flip it over your head.
But the investment and the risk are enormous. For the last 3 years, we've been following the process of designing, manufacturing, and testing the world's largest and newest twin-engine airliner. It's cost an estimated $5 billion. Boeing needs to sell 200 or so planes at roughly $100 million apiece before the company will consider the plane a success. Back in mid-1992, Boeing began assembling and training the 10,000-strong team whose excitement and disappointments would punctuate the complex process of plane making.
How are you?
A key figure in this drama was Alan Mullally, the 777 director of engineering. He had a boyish charisma, a fierce pride in his company, and he was determined that the new plane would succeed.
Best airplane company in the world.
But in the time since Boeing had developed its last airliner, the aviation industry had changed. It had become harder to hold on to a share of the market.
What's different with the airlines? They have choices. They have choices. They haven't had so many choices before. All except the 747. Airbus has an airplane that can match every one of the Boeing airplanes.
Hey, Ashu, how are you, mate?
So
Welcome,
they have
mate.
choices for the first time in history.
This new competition had come about because of a gap that opened up in the commercial aviation market. The airlines wanted a long-range plane that was smaller than Boeing's 747, so Boeing's two rivals started manufacturing new planes to fill that gap. Airbus with its A330 and 340, and McDonnell Douglas with the MD-11 and 12. The 777 comes somewhere between a 767, a 200-seater, and a 747, which can carry up to 425 passengers. When the company first decided to enter the race, they hoped they could expand the 767 in ways that would satisfy their customers. Boeing took these designs to various airlines. No one was impressed. British Airways, for example, dubbed this a chipolata sausage. In October 1988, the design team met with Boeing's senior executives.
We had, at that time, I think 7 product scenarios, all focused on a 767 derivative. And at the end of that 5-hour meeting, a simple question was asked: why haven't you looked at a new airplane? And our answer was, we really haven't done it yet. We'll go do the homework. And the next question was, when can we look at some data? And the answer was the last day before Christmas break in 1988. So we went back to our team, which at this time was about 200 people. and said, let's start working on a new airplane.
Boeing had done all this before. From its base in and around Seattle, the company had designed and built
Where are you
6
tuning in
different
from,
airplanes
Ashu,
for
if
the
you're
world's
still there?
airlines.
Sorry, I was AFK.
By the end of 1988, they had decided it was time for a 7th, in spite of the huge financial risk this involved. And the risk would increase over the following years as the world moved deeper into economic recession. When President Clinton visited the Boeing plant early in 1993, he reminded the assembled workers of how bad things were for the airline industry.
And it is indeed ironic that the United States, which for so long has led the world in the production of airplanes, has had 3 years in which more money has been lost than was made in the previous history of the airline industry.
The economic situation would prove a constant source of anxiety for the plane makers as they got underway on the 777. Particularly for the executive in charge.
I was a young engineer here in 1969 when 2/3 the Boeing population left during the period where there was a big sign outside that said, outside of Seattle, that said, "Last person out, please turn out the lights." That clearly has affected the way I think about organizations and stability of organizations. Be more careful when you're going up, because on the other side of up is always down. We went up way too fast. We weren't efficient in the process, and so when we got to the top, we were way overmanned, and the far side was very steep. Don't want to ever do that again.
To justify the huge investment in the new plane, Boeing needed a launch customer, an airline that would commit to buying a significant number of the new planes in advance. They naturally turned to United Airlines. The two companies had been partners in the early days of commercial aviation. This is United's first Boeing airplane, the earliest all-metal transcontinental passenger airliner. The company has since bought more than 1,000 Boeing airplanes. But the historical relationship between the two companies counted for little when it came time to make the deal. Gordon McKinsey of United.
So we went through a rather large evaluation process in 1989 and 1990, where we were looking at 33 combinations of airplanes and engines for our wide-body purchase. And this was just one of the candidates. The 777 was up against the Airbus and the McDonnell Douglas airplanes.
The sales campaign came to a head on the weekend of October 13th, 1990, when all three manufacturers, Boeing, Airbus, and McDonnell Douglas, were summoned to United headquarters in Chicago to make their pitches. Boeing was asked to sign this handwritten piece of paper. It played a crucial role in the decision, as Alan Mullally would later tell the 777 team.
It's a piece of paper that Jim Guyette, who's Executive Vice President of United Airlines, wrote at 2:15 in the morning. He woke up in a cold sweat. He's going to walk in and see Mr. Wolf, who's the Chairman of the Board of United. He had the Chief Financial Officer that was voting for Airbus instead of Boeing, and he had to walk in and make his vote. What airplane should United Airlines go with for the next 30 years?
It was a hard-headed and unsentimental business, with each of the three competitors in separate rooms, running in and out of a room full of senior United executives who were trying to make up their minds. An executive named Dick Albrecht led the Boeing sales force. Phil Condit, as leader of the 777 team, wondered whether he should go to Chicago too.
I talked to Dick Albrecht, said, you know, do you need me there? And his answer, and I believe correctly, was no, I think we've got our pieces, we'll go try to put the deal together. So I said, okay, well, here's my phone number. I'm gonna be at my younger daughter's parents' weekend at Colgate University. And I'm available by phone. I'll check in.
Well, it was emotional because
when we went in there, I think it was a Thursday morning, we were told by the senior VP of Finance that we weren't leaving that building until the deal was done. So we'd all checked into local hotels, and we were there watching the sun rise over our corporate headquarters twice.
After a while, I was reasonably certain that the phone was probably broken because it didn't ring. Sitting there watching it, nothing happened. So I called Chicago. They said, we're just sitting here, but we expect something in the next couple hours.
You know, we went into 70 hours of nonstop negotiations. And it was very emotional because we could tell by the faces on the people coming out of the Inquisition chamber that things had not gone well. You know, what was happening, of course, is, you know, somebody would go in there from one manufacturer, and a deal would be presented, and then he would be dismissed, and the next person would come in, would try to better the deal. So it was a ratcheting process through those 70 hours, trying to get the best terms.
So finally, at the end of the day, things were still sort of about to happen. I said, I can't stand this any longer. I got on the airplane, went to Chicago, and went and joined the wait. Sat and talked and worked on a crossword puzzle.
Technically, we had made our decision. We knew what we wanted to do. So we had our technical recommendations already in place. And the 70 hours were really just financial negotiations, terms and conditions, a lot of contract talk. But it was emotional.
Then they sort of finally came in and said, well, we need to see you in Jack Pope's office. So we went down there and they said, you've got the deal. I was glad I was there, and it was exciting to be there. My contribution probably can be measured in very small numbers at that point. You know, it was just being there.
What clinched the deal was the agreement put in front of Boeing by Jim Guyette.
So he wrote a handwritten note at 2:15 in the morning saying things like, we agree to work together, you know, really complicated words, to deliver a service-ready airplane, an airplane that works. It has the functionality, the passengers like it, the attendants like it, the maintenance people like it, the flight crew likes it, and we agree to work together to make that happen. And then he dragged Phil Condit and Dick Albrecht into the room, and he said, will you sign this? And they said, and he took that to Mr. Wolf, and he said, this is the new Boeing. The new Boeing is going to treat us at a new level of respect as a customer. The reason I wanted you to know this is that that meeting at 2:30 in the morning has changed my life. And it's going to change yours. I've been waiting for 4 years for you to arrive because it's time to make an airplane.
United Airlines agreed to buy 34 777s for delivery in 1995 and to take an option on another 34 for delivery 3 years later. They had committed to spending $3.5 billion on a plane that didn't yet exist. The plane United bought would have a number of important features. It would be powered by just 2 large engines. It would be guided by a state-of-the-art electronic control system, and it would be built from the newest and most reliable materials. It would also be a very big airplane. Not quite a jumbo, but not far from it. The diameter of the engine would be as wide as the whole fuselage of a 737, and the horizontal tail would be equal to the 737's wing. But it was the interior of the plane that most interested the customer. To show off the interior layout, Boeing spent hundreds of thousands of dollars on a life-sized mock-up. It would be an essential sales tool. Early on, Lord King, chairman of British Airways, was given a guided tour.
Hello.
Lord King is shown an important area at the back of the mock-up, called by salesmen the dirty pool, with an emphasis on how the 777 would compare with the competition.
So all the wide bodies flying today, because what we were after was, you said make it bigger and make it roomier. Well, this is what people are used to flying. Here's the contour, and here's the bends. Here are the bends. here's the 777, the 5 inches larger. You can see the contour and then the effect of the bend. Okay,
All right, let's look at the
back.
In previous Boeing planes, full-scale mock-ups of the aircraft, inside and out, were not just marketing tools. They performed an important role in the design process. With the 747, for example, Boeing built several life-size mock-ups of the whole plane, with every part modeled in detail before the design was finalized. It was the only way the engineers could see whether or not the pieces fit together. Because of the three-dimensional complexity of the plane, a component as first designed often got in the way of the structure or one of the other parts, like these red pipes, which are not meant to go through the yellow duct. With the 777, Boeing wanted to find ways to catch these interferences, as they're called, before the assembly stage.
You have 5,000 engineers designing the airplane. It's very difficult for those engineers to coordinate with two-dimensional pieces of paper. For a designer who's designing a air conditioning duct to walk over to somebody designing structure and say, now here's my duct, how does it match up with your structure? And they've got two-dimensional pictures, very difficult. So we ended up using the mock-up and, quite honestly, the final assembly line to finish up the integration. And it's very costly. You end up with an airplane that's very difficult to build.
It all has to do with visualizing 3 dimensions on a 2-dimensional drawing board. One of the trickiest problems was working out the lengths and angles of tubes, pipes, and wires.
We would literally, physically thread the systems through that mock-up, and then, in the wire bundle sense, take it out of the mock-up, flatten it on the board, measure it, and that's the way we decided how long the wire needed to be. And then you would adjust as necessary, because the airplane, not made of plywood and aluminum, differs from the mock-up. So as you produce those first wire bundles, then you make further adjustments to make them fit the real airplane. Hydraulic tube, a very similar situation.
The solution was a secret weapon called EPIC, a computerized design system that would require 8 mainframe computers to run it. Engineers would be able to roam the virtual interior of a plane that didn't yet exist. As pieces were designed, they appeared in the virtual airplane next to other components, and the team could check to see that they all fit together before they were carved out of metal.
So for the first time, the engineering creative process was enabled to think in terms of the way the world is, in terms of 3 dimensions. Now, computers don't design airplanes. We have not put the knowledge that's in the airplane designer's head into artificial intelligence that balances all these objectives. Someday, we'll continue to probably move to that end, but right now, the knowledge to design airplanes is in the designer's head.
There would be more than 2,000 computer terminals, so that each group of designers could feed their drawings into the main computers. In June 1992, the passenger doors team was checking for interferences in the components they had designed. An interference showed up in red. The designer was concerned about 2 crucial components in the door hinge.
This splined part right here, there's a bolt passing through it. It's actually the connection of the door to the door frame, the cutout. And this bolt affects that connection. Somewhere inside there we've broken some law. Now that looks like a real interference. This is what happens when you accommodate your stress man's desire that they be intimate. They interfere for the entire head of that bolt. But the actual amount it interferes, we really tell by cutting through the 2 of them and looking at an accurate cut, which doesn't take hardly any time at all. Now this, yes, the second circle is just a little bit larger than the first circle, and I do indeed have a little problem here. But it's a very small one. We haven't released any drawings yet.
Another innovation on the 777 would be a new method of organizing the 10,000 or so people building the plane. On past projects, airplane design had been bedeviled by communication problems between the many different divisions in the company. For the 777, Boeing would create new work groups called Design Build Teams, or DBTs. They would include people who had never before worked together.
I wish that I could say that design build teams were sort of one of those wonderful ideas that sort of leapt forward and you said, aha. In a lot of ways, it is a return to some things that have worked in the past that were scale driven. If you go back to the early airplanes that Boeing built, the factory was on the bottom floor, engineering was on the upper floor. Both manufacturing and engineering went back and forth. When there was a problem in the factory, the engineer went down and looked at it and said, well, you better do this. The entire design department was within 50 feet of each other. As the scale went up, that gets harder and harder and harder. And if you're not careful, organizations, just by the way they behave, want to form little enclaves. So structures goes off over here, and air conditioning goes off over there, manufacturing goes over here, and planning goes over there, and finance goes over there. And then one day you turn around and you've discovered there's an us and them attitude. If only they would do this, then our job would be easier, and if only they would do this.
The passenger doors were designed by one of over 200 design build teams, each responsible for a major component. Making an airplane door that works involves the complex interaction of geometry, materials, manufacturing, and in-service maintenance. At one point, this team faced a problem that brought up all these factors.
That's a full-size drawing of the two cutouts in the door skin that are located very closely together. And again, our principal concern is making sure that with all of the parts that have to be integrated into this area and the fasteners that have to be put in the skin, do we have enough room to do all of that? And will the assembly be durable and damage tolerant?
The problem involved a metal area of the door skin between the window and the door handle cutout that was uncomfortably narrow. The designers have two questions. How strong a force would produce a crack in this area? And if the metal did crack, what force could enlarge it and lead to the door failing? They get two different figures from the stress analysis engineers. It would take a force of 27,000 pounds per square inch to crack the metal. But once a crack had formed, the force of 12,000 pounds would be enough to open it up.
That's the way we perceive the situation. 12 is the upper limit at which the crack will not grow. And in this area, there's not much room for a crack to grow. We're very tight.
I guess the problem, what's still not clear in my mind is, for the identical area under the identical consideration, are you getting a recommendation of 12 from one guy and 27 from another?
Yes, for two different reasons.
Right. And if you follow the first guy, you would in all cases restrict the stress to 12.
Yes.
And the second guy says, as far as he's concerned, you could go to 27, but he's not considering the other requirement.
That's correct.
Okay.
That's correct. We could work it to 27, but if a crack should start, it's going to grow right across the area.
Okay.
If we hold it to 12, it immediately satisfies the other one.
Okay.
That's all we're saying.
There were four possible fixes involving thickening the existing metal or adding an extra layer called the doubler. However, since any cracks would be easily visible, perhaps they could just ask the airline to keep a lookout.
Just call for a special inspection in that area. That's an alternative.
True.
Not pleasant, agreed, but it's an alternative.
Especially since we've already told United we won't have any of those.
That's right. But this happens to be on a door that gets frequently used. The number 4 door is supposed to be one of the most frequently accessed for loading the aft galleys and so forth. It may not be much to have an experienced person show up there every so often and just take a close look instead of having to have something leap out at you and say, I have a crack, I have a crack.
I understand.
It took another 4 months to solve the problem entirely by designing an extra layer called a doubler to go behind the outer skin.
Well, if we just left it a skin without this doubler here, it may be strong enough for static strength, meaning it can take the pressure of the airplane, but over repeated pressurizations, eventually it would get tired, it would fatigue, it would crack, and the crack would then go across here. The airlines would catch the crack, and then they'd have a very difficult maintenance job to go in and repair it, perhaps putting the doubler, maybe one like this, on the outside, which then is drag and et cetera. So it pays us to figure this all out ahead of time and put it in behind.
In mid-1992, while the team was still designing the door, they built a prototype for a very important cold weather safety test. The engineers wanted to see if the door could be opened in the worst imaginable conditions of icing on the outside of the fuselage. The first stage of the test involved spraying the door with water all night in a low-temperature chamber until there was a thick layer of ice.
Welcome to the Bahamas.
But how could a plane ever get into such a state?
If a plane lands from a cold flight, -65, and comes into an airport where, let's say, it's about 28 degrees, there's freezing rain, and it pulls up to the gate, and this freezing rain is then adhered to the outside of the airplane, we need to make sure that we can open the doors. Our criteria is a 1/4 inch thick of ice all over the whole airplane. And yet, at the same time, someone with nominal handle force on the inside can indeed open the door. We consider the ice to be as strong as 100 pounds per square inch to break it. It's a 1/4 inch thick, and there's about 200 or so inches of ice around there. So when you factor all that in with safety factors, it's about 6,000 pounds of lift that has to be put on the door to make sure we break all the ice. And that has to be put in with about 50 pounds of handle force on the inside.
Set up as quick as we can.
The following morning, the door had acquired a thick enough layer of ice to test the mechanism.
It's -20 in there right now. It was -55 in there yesterday when we sprayed the water to make sure it iced up. Considerably colder yesterday. -20 is not so bad.
This test had never been done before on this door design. If it didn't work, the engineers would have to redesign the complicated opening mechanism inside the door.
Boy, it's nice. This is a big key test, and it worked great. Feel real good about it. Right.
Another part of the plane that was being tested long before the 777 existed was the flight control system. Boeing equipped one of its smaller planes, this 757, with a prototype of a brand new system that would be used in the 777. They had to test it in flight.
Right now I'm holding a lot of column force.
These tests came after many months of testing in simulators on the ground. The new system was called fly-by-wire.
I'll go to 10,000 feet and about 250 knots, and we'll stop there and do some evaluation.
Fly-by-wire is an unfortunate term. Probably electronic flight control system is as close as you can come to the real definition. But it's simply the idea that we use electrical wires rather than mechanical cables to transfer signals from the front end to the back end of the airplane.
Boeing's chief test pilot for the 777 was John Cashman. He would be the first to fly the plane once it was built. He quickly understood the advance that fly-by-wire represented over the more cumbersome system then in use.
An airplane, particularly a large airplane, has large cables that run from the cockpit controls to the actuators that move the surfaces. And almost all big airplanes are hydraulically moving the controls. Those large cable runs are very difficult to rig and very time-consuming to maintain them in rig. So from a maintenance side, it's a fairly big improvement in terms of time to maintain. The changes that one can make and improvements that you can add to an airplane are much easily done if it's a computer card change versus a mechanical redesign.
There's a pilot's joke about fly-by-wire systems that says that modern planes could be flown by a pilot and a dog. The dog to bite the pilot if he touches the controls, and the pilot to feed the dog. In fact, the computer systems that would be installed in the 777 were so intelligent that engineers believed they could make decisions that would be as good as those made by the pilot. But Boeing stopped short of letting computers fly the plane. It was a question of safety.
The biggest disadvantage from a safety point of view is the potential that you haven't thought clearly through all of the events that may occur and taken enough precaution. There's an apprehension anytime you change technology, and particularly when you switch from mechanical, which is visible, to electrical, which is not. And so to some extent, we've taken a conservative approach to make the airplane fly like a conventional airplane from a pilot's point of view.
One of the things that we do in the basic design is the pilot always has the ultimate authority of control. There's no computer on the airplane that he cannot override or turn off if the ultimate comes. But in terms of any of our features, even those that are built to prevent the airplane from stalling, which is the lowest speed you could fly and beyond which you would lose control, we don't inhibit that totally. We make it difficult, but if something in the box should inappropriately think that it's stalling when it isn't, the pilot can say, this is wrong, and he can override it. That's a fundamental difference in philosophy that we have versus some of the competition.
The 777's computers, which were being tested on the 757, would translate the pilot's instructions into commands to move what are called the control surfaces, movable pieces of the wing and tail that allow the plane to change direction or altitude. This flight was one of a series to test how the fly-by-wire system felt to a pilot when he landed the plane. Like all testing on this new plane, every aspect of the test would be analyzed and discussed to see what lessons could be learned before the design was finalized. The process began with the post-flight briefing. The two pilots reported on how the plane felt as they landed it with the fly-by-wire controls.
Well, you're the third pilot now to have an experience like that, not unique to C-Star-U landings, but simply on various landings reporting that your initial flare input generated a result greater than you anticipated.
You actually do that, you think, oops, you back off, and you always back off too much.
Yeah.
And then you end up with a Navy landing.
Uh-huh. That means good landing.
Which, by Frank's definition, is an excellent landing.
Yeah.
In early 1992, the team was under tremendous pressure as weight, cost, and design targets had all been exceeded. They scrutinized every aspect of the project, including travel costs for engineers who were flying from Seattle to meetings with subcontractors in other parts of the world.
We looked at the cost of travel. Right now we travel business class. And for my group, the difference between traveling business class and coach with what we project our tests are going to be, testing support and meetings, is something the order of $700,000. Now, we're at a stage of the game where I'm not going to piss my guys off and say you travel coach and everyone else travels business class. So what I'd like to propose is that the 777 program proposes that when we go to UK, we fly coach. I think we could save a tremendous amount of money.
I have a guy who's fairly big.
Well, I think,
and
so do I, and I think we can make an exception
and it is
for that.
bloody uncomfortable.
Yeah.
For that length of flight and then to carry on a meaningful meeting next day.
But we did this for years and years. It's only in the last 5 years or so that we've started to fly business class.
Why don't you, let's do what Hardy said and pass that and see what kind of reaction you get, and then let's bring it up next time.
It would probably have been unfair to ask if the economy seats in existing planes were too narrow, who designed them, since it was the airlines and not these engineers who decided how many seats to put in a plane. The next item dealt with another thorny subject, office space. With a move to new offices coming up, there was some contention on how the new offices had been assigned.
Some of my supervisors have come in to me about the move to Everett and said they thought that all first-line supervisors were in cubes, but they hear that some first-line supervisors are in offices.
Not in engineering.
Yes. Engineering.
Tell me who they are. Because we worked it so that it was supposed to be
On
that
the
way.
floor that I'm on, there are first-line supervisors in offices, and they're not payloads.
Will you tell me who they are?
I'll write it down for you.
Because they tell me that we fixed it. Alan decreed.
We still owe them engineering.
New terminology came thick and fast at this stage of the project. Too fast for some members of the team.
We do that. MCs are
Okay. Requirements for SDS items in APL, Raj, next week.
I forgot what an SDS item is.
It's a shop distribution standard.
Okay.
We'll also show you the PRR process
With delivery schedules becoming critical, tempers began to flare when one engineer felt he was being delayed by another.
I've taken a lot of flack over that. Item 8 was the wrong one to put in. The thing that we agreed to put in is when structures returns to data set.
No.
My man told me.
No, we all agreed.
We all agreed. Even showed him the chart.
I showed you the chart.
But,
I showed you what
that's useless data. Most of it is obsolete. Because
it's not useless data.
It is.
I'm missing releases because you did not transfer on the date the agreed to information.
Because you didn't transfer to me.
Oh, baloney.
Anyways, that's the wrong date.
No, it's not.
I did it.
Oh, okay.
I sat there for 5 minutes 2 weeks ago and explained it. I showed you an example. Everybody jumped on.
Why are you talking to me? I agree.
You guys agreed? Yeah. It's done.
It's done.
In spite of mounting pressures, there was the occasional good news. One of the team reported on a foreign airline whose government was deciding on the purchase of 6 777s. The 777 had been up against its main competitor, the Airbus A330.
And the cabinet had approved the 6. And then they said, well, we think that may not be right, and what we think is we probably ought to add 2 more. So instead of approving 6, they approved 8. And then they also did not approve the 8 A330s. Or sorry, 7 A330s that they were asked to approve.
All right. Nothing like winning.
But there was no disguising concerns about the task that lay ahead. They were just 9 months away from assembling the first piece of the first plane.
Roger, do you have anything else?
Yeah, I have something to say. I'm worried about us. I'm worried about our recovery. We're behind schedule, and what I see is it's going to take a long time to recover. And I think we really need a recovery plan. And I don't think we have one.
Okay.
And I'm
Roger
really
was reflecting that we keep telling each other what we really need, and we keep trying to help each other, because in the heat of getting your own stuff out again, the first thing that you let go is coordinating with your, with your colleagues. And Roger is just trying to remind everybody, you can't worry by yourself.
Underlying the building of the 777 was a new kind of organizational philosophy Boeing had dubbed working together. This easily dismissed slogan masked what amounted for Boeing to an internal revolution. For the first time, Boeing would be guided by principles that encouraged, even forced cooperation. First and foremost, there would be no secrets. Information would be shared openly, even when things went wrong.
We had to make some cultural changes. I guess that's the best way to put it. We had to open communications. We had to break down traditional barriers between organizations. We had to come up with forums where the people could speak up, and more open communications and more frankness coming from all levels to management or vice versa.
It was a point of conflict to begin with. You know, an engineer with pride wants to find the solution to his problems. And it's not a natural thing to go out and explore publicly the particular problems you have. You'd like to do it and be able to handle those yourself. So I'd say, yeah, there was resistance at first, but it's interesting what attention can be given to a particular problem like that, communication problem, if you will, in that regard, by just making it okay to do that sort of thing. That the thing to do is to express your problems, get all the help you can. If you're working together, you're going to find that a great assistance in finding the solution, because none of us singularly can do nearly as well as we can as a group. And so I think over the years that's gone away. I think we kind of shout it from the rooftops in our program reviews with large audiences, in our all-team meetings. It's been said, the same words have been used. It's okay. It's almost like celebrate our problems, get them out in the open so we can go work them.
One of the areas of the plane getting a lot of early attention was the interior, the part that would sell tickets. Less visible to the passenger, but equally important, was the design of the cockpit.
The color scheme we kept basic, the same as the 747. And the reason why is because there was a group of people who did a study on color, and they found that warm colors like brown were more inviting to a pilot, and also it kept them more alert. And also we found that brown hid more of dirt than any other color.
But the pride of the 777 cockpit would be the cup holder.
For the coffee cup holder, we come up with concepts first in the drawing, and then we make them out of cardboard. And after we finish our design that we think we like the best, we start casting them. And these are the two that we casted. And so we refine them. So what you have in the flight deck right now is the refined version. And what's also nice, we came up with the idea that it could be removable, because we know that over time that the beverages would spill and stay sticky. You want something that's easily cleanable. And these are some of the samples: pop can, styrofoam cups, airline cup, and they all fit. And we also had to take consideration of the height of the handles, just to make sure that it does fit into the holder itself.
Boeing was also proud of its new overhead bins, which seemed to demand a technology and a jargon all their own.
We have three sizes of bins, and those bins can be shuffled to any arrangement to sneak up to outboard monuments. We call them monuments, labs, closets, galleys, etc. But more importantly, in the past, each one of those monuments was very static and had to be tied straight back to structure. In this design, this fore and aft member allows that unit to be translated fore and aft in the cabin on 1-inch centers anywhere in the airplane in prescribed flex zones that allow load path capability in the overhead rail.
The Japanese were expected to be one of the largest purchasers of the 777, but would be among the shortest in stature. Nichols finds a diplomatic way to refer to this fact in describing the design process.
This is an issue with our customers, more so with our Pacific Rim customers than for instance, European customers, the American carriers. And it's flat the height, it's the ergonomics of the latch, and some of them feel that it's a bit too high. Now on a pivot bin, it must be this high to reach the latch, but once it opens, then the access to the bin is more than acceptable and more than appropriate in terms of a shelf bin. Where the shelf bin remains static, you hit a latch that's quite low, and the door swings up, and now I'm reaching up here to grab the door. So the latch handle, though our customers have expressed some concern, they've all been through the mock-up, and they understand our design, and to physically move that, that's something that would be, demand a lot of effort, and believe me, we can't do anything, but we've, if you will, pounded our stake in the ground and believe ergonomically and demographically this is the right latch.
A part of the plane least likely to be the site of technological innovation were the lavatory seats, but Alan Mullally liked to tell the story of the airline that came to him with a problem.
In the lavatories, when a toilet lid or a toilet seat falls down in the toilet bowl, it makes what they called the big hit sound, the big bang sound. And they found that that was very distressing to the traveling public. So we went to work. We got the mechanical designers, the electrical designers, and the toilet suppliers and makers of toilets and toilet lids. We got them together, and we started to work on a small device that we could put on the back of the toilet lid. You see this device right here. And this little device could go on the toilet lid, and we could put another piece out the other side that could hook onto the toilet seat. And we could absorb the energy of the toilet lid and the toilet seat before it hit the toilet bowl. So we could slow the lid down, slow the seat down, so that the big bang sound went away.
Think how people are going to feel that when they put the toilet seat lid down, it goes like that. They're going to feel like they're in a quality airplane. Now this is a customer-in toilet seat lid.
The first year's work on the 777 involved designing the new plane. Now, manufacturing would get underway. It would begin as the first component of Boeing's brand new aircraft, a wing spar, began assembly on a giant automated riveting tool. This piece was a long, thin metal spar that would run the full length of the wing. Over the next few months, the rest of the wing would be built up around it. Sylvia Lefferer had the informal honor of initiating the process as she began her job of sealing the edges of the 100-foot-long piece before it was fastened to other components. It was a simple process involving an injection gun and compressed air.
Something's wrong.
At least it was supposed to be.
We got a problem. We got no air right now, so we got to try to get that hooked back up. Well, it did for a minute. Maybe it just bled out.
Once the air started flowing, she smeared a layer of gray sealant along the piece. After years of doing this on other planes, she could produce a layer of constant thickness the entire length of the piece. The work had to be checked by a quality control inspector. Too thick a layer would add weight to the plane. Too thin and it wouldn't seal properly or prevent corrosion.
Looks good. Thank you.
Sylvia's work passed inspection and the pieces were moved into contact with another component ready for fastening. Then there was another small problem. The upper piece of the spar was out of position by a 50th of an inch.
The lower chord's at its locator, and the upper chord's 20 thou outboard of its locator.
You mean this one index up like that?
That's correct.
Can you just take a big seat map and tap that?
piles are used to provision of the tool, what it was built to do.
To move this way?
Yeah.
Okay, let me see. I've seen.
That's what this ratchet handle does here. See, you clamp this here, and then just hopefully move this upper cord inboard. Ready? Ready? Okay. Good. Now watch.
Over in the 777 team's brand new office building, Alan Mullally arrived for work. It was just a few days after Christmas. Mullally hadn't had much of a holiday.
But I came in on all but 2 days. But it was kind of a nice time. It was almost like a time to kind of reflect on the past year and think about the priorities for '93. We had quite a few people working, especially in engineering and in operations and planning and tooling, that were supporting the first parts of assembly. So I talked to quite a few of the structures engineers and the planners and the toolers associated with structure, just to get a feeling for how they saw it, what their problems were, and challenges and stuff.
Although the team had started assembling the wing, the design of the plane was not finished.
But really, the way we lay out the program is that we stretch that process over nearly 2 years. So what determines what parts are going to be designed is the sequence of when it's going to be assembled. So the actual design of all these parts is spread over 2 years. So even though we're seeing parts being assembled for like the front spar, those are the parts that were designed first, because those are the parts that need to be built first. But right now, all the payloads area, like all of the bins and the C-tracks and stuff, they're just being designed now because they'll go into the airplane later in the sequence.
The beginning of assembly was a significant milestone in the life of the 777. But now there were only 18 months till a piece of metal in this tool would fly, along with 4 million other components, on the airplane's first flight. And as Mullally looked ahead, he and his team faced an ongoing recession in the aviation industry. How would this affect the fortunes of Boeing's new plane?
It's so important for us that we absolutely will not let the current events affect our intensity on getting this program done, because this is such a long-term business and these projects are big and they're made for the future, that we just can't let the anxiousness and the ambiguity of today's environment in any way slow us down. And so we talk about it. We talk about it openly. We talk about every cancellation. We talk about every airline that gets in trouble, every airline that has to go into Chapter 11, bankruptcy, and what it means to Boeing. And we talk about what's happening to Airbus the same way, and what it means to us. And it's okay. It's really important that we talk about it. And then we move on to what our real job is, and that is stay focused on developing the airplane for the future. And that's our strength to keep going. But it is worrisome.
The team's morale was at a low point, but there was no stopping the plane-making machine that had lumbered into action. They were committed to building the 777, whatever the challenges, and there were certain to be more of those in the months ahead. At the beginning of 1993, in a new factory just north of Seattle, an assembly line awaited the first components of the Boeing company's latest airliner, the 777. It was a significant moment, a culmination of 2 years' work. Three strips of metal forming the front wing spar for the first plane were being riveted together by a huge computerized tool. By the time this plane is completed, there will be 3 million fasteners like this one, holding together several 100,000 parts. 18 months from today, the number one plane would have to fly. But this schedule was all based on faith. Faith in a new approach to plane making that had taken an estimated $1 billion to develop. Previous Boeing airliners had sometimes suffered from costly errors in the manufacturing process. To minimize such problems, Boeing was determined to improve communications among the 10,000 people who were going to design and build the 777. The company would adopt a new management philosophy, known by the slogan, "Working Together." For the first time at Boeing, this plane would also be designed almost entirely by computer. The inspiration for all this came from an unexpected source. The 777 team leader recalled the lessons learned from assembling his children's Christmas toys.
Fisher-Price does the best job of any toy company on making toys that are easy to fabricate and assemble. Fisher-Price makes a little notch in their wheels so that you only can put the right wheel on the right hub, you only can put the left wheel on the left hub. You also use simple tools. So I started saying, you know, what we're after on this program is not just meet cost targets, not meet just add value to our airline customers, but we're going to do that by doing what Fisher-Price does on Christmas Eve. We're going to make this easier to fabricate and assemble. So one time as a present, the engineering guys, after we started to incorporate all the producibility, they gave me a whole bunch of Fisher-Price toys so I could pass them out and make the points to the engineer.
The task facing the plane makers was enormous, and the outcome was by no means certain. Pieces of this plane would be made all over the world. In Britain and Italy, Canada, and other parts of North America, Japan, and Australia. And there were two key questions. Would the pieces arrive on time, and would they all fit together as planned? This was a brand new plane, made with new materials, guided by computerized electronic controls, and powered by two of the biggest jet engines in commercial aviation. It would also have the largest rudder in the business, but it was this rudder that would create the biggest cliffhanger of the coming year. The problem started during the design phase. Like all the components, the rudder was designed by a group of engineers called a design-build team. The team included designers and manufacturing engineers, as well as representatives of the company that would make the rudder in Australia. The working together concept was meant to highlight problems quickly and eliminate arguments as the problems were solved.
But legally, for 777 legally...
But tempers rose when the rudder design was changed after the Australians had already begun making it.
Process spec deviation.
Excuse me, what I'm saying is a process is defined right now, and that's what we have to work to. And
but the process right now says we got an X-ray.
That's right.
We're not going to.
Well, I'm just telling you that you have to, you conform to the process as it's defined.
Can't fit it in the room.
Well,
no, it's not an option.
I'm just telling you, that's something you have to contend with, and that's why, you know.
That's why we want them to buy it.
In a computer analysis, Boeing had discovered that the rudder might develop a troublesome vibration under certain flight conditions.
You're looking at a 10 to 15% increase in rudder stiffness, or in the total loop stiffness, to solve the problem. I'm going to head down to Australia and face the teaming NASAs aren't happy with this.
The teeming masses were the engineers and executives at a small company in Melbourne called ASTA. ASTA had won the contract to build the rudder. Initially, they were delighted.
It's a bloody big job.
They were much less delighted when they got the news that the design was being changed after they were already underway on the prototype. The rudder consisted of many carbon fiber layers laid in a precise pattern and then baked in an oven. Much of their effort to date was now wasted.
Putting those cheese off the blazes because of this change. And I'm not exactly that happy today because we set out to achieve a whole series of things with this particular rudder skin. We'll achieve most of them, but probably the thing that worries me a little bit is that the configuration will change, and it's going to change fairly dramatically. And we still have to deliver on schedule. We've got a requirement to deliver this rudder in the middle of next year, and if we're late on that, it puts Boeing in a bind. And we don't want to do that if we can possibly avoid it.
In any large airliner, the rudder plays an important part in controlling the sideways movement of the plane. In the 777, powered by just 2 large engines, the rudder had a particularly important job to perform.
On this particular airplane, the key task is to allow us to keep the airplane flying in the right direction if we lose an engine on takeoff. It's with a large twin engine airplane, it's a key part to making the whole system work.
The problem was an unwanted vibration involving the rudder and the piston that would move it, called an actuator. ASTA was now behind schedule, but the rudder was such a key part of the plane, it had to be delivered on time or it would hold up the whole assembly and testing process. The ASTA team met to discuss the situation.
What we really have to address is quite clearly the effect of all these changes that are being brought on to us by Boeing. Lovely company though they may be, they've given us a real problem insofar as building this rudder to schedule, because the changes effectively are the skin gets changed by the addition of something between 2, 4 or 6 strips or plies of tape plus some additional fabric. The actuator fittings in the actuator area become titanium, and there is a whole lot of extra machining on some of the other ribs.
There were major concerns at Boeing over whether or not the rudder would be delivered on time. Any delay could throw the whole plane off schedule. As the newly appointed Director of Engineering, Ron Ostrowski was worried.
It complicates schedules for certain, because we wouldn't have anticipated having this problem this late in the game. We wouldn't want it this late. So, like ASTA in Australia trying to produce a rudder, if we have to reinforce it, it affects them. But these things crop up, you know. There will never be an airplane that's perfect right out of the chute. I mean, it's too complex a vehicle to ever expect that to happen, and changes occur, and we have to just recover from those as they happen.
We've had 2 major redesigns so far, and whilst this one looks good, the previous one, the solutions there look good. Hopefully this one's better and this solves the whole problem, because after this, I don't know what the hell we would do if there was another stuff-up.
Another design change, or stuff-up as Tyler put it, was all too likely. Only time and further testing would tell. In Boeing's own plant, north of Seattle, a giant machine was lumbering into action to assemble the first plane. Within a 30-mile radius, Boeing had a number of plants that were making various components for the plane. The components would then be shipped to the main plant for assembly. This is one of the largest single pieces of the plane, a carefully shaped aluminum wing panel, stretching 100 feet across the factory floor. The plan was that major sections of the plane, starting with the wings, were to be assembled from hundreds of smaller parts, which would be milled and shaped in the various Boeing plants. The larger sections would be transported from where they were built to the final assembly line. Between each of these stages, the growing plane would be moved from one part of the assembly line to another by a series of enormous cranes. In final assembly, the last stage before the plane left the building, the 777 would acquire its two huge engines. But that was still 9 months away. As the first wing took shape, individual pieces were being sealed so the interior of the wing could act as a fuel tank. Glenda Barnes was one of the wing sealers. The working together approach had definitely affected her job, compared to the way things had worked in the past.
I'm a sealer, and if there was a certain bracket, such as this one, that I knew as a sealer that did not need to have seal on it, but the plans as of now said to seal it. Well, before, I would have to submit a request stating why. Then that would have to go from one place to the next, and by then, there's 2 or 3 airplanes that's out the door, but this bracket is sealed. Now, I can pull together with the other team, and I wouldn't have to seal this bracket today. That's how fast some things can happen now. Say after I have done my first 2 processes, then I have to call quality control to come and look at my process. And then they thoroughly go over it to make sure I have sealed in every place that I should seal it. And if I haven't, they will tape it and let me know. And if I have, they will give me the okay to go ahead to the next process. You know, I get upset sometimes if I miss something, but we all have those bad days and those good days, so. And they are there to find those things that I may have missed.
Boeing calculated that their new methods had meant an 80% reduction in the sort of errors and changes they had experienced on previous planes. The floor beams had come together with an accuracy that was down to the 4th decimal place. They held the seat tracks, which were made of aluminum, except in the galley areas where a corrosion-resistant titanium was used.
The reason it's more subject to corrosion is spillage of pop, Coca-Cola, beer, wine, that type thing. It's very corrosive to the aluminum metal, but not the titanium. You want to make sure that the seat is always held. Whatever in the seat, this is one of our, and I know it doesn't look like very much, but it's a very concentrated area for stress when the seats, you know, in a crash load or something like that, it's very difficult. You have to make sure that you can survive a 16G crash.
In the past, the designers in their offices would have designed a component and then washed their hands of it once the drawings had gone to the factory floor. Now, they were involved throughout.
That's really interesting there. We have some manufacturing engineers working with the mechanics. Now, these guys are from the office building, the engineers from over there, and they're coming out talking to the mechanics, something that you would never see in the past. It is absolutely the only way of doing business. Before, I couldn't find an engineer. And now today, I have to ask them to leave so we can build. They have to just quit designing so we can build.
The floor beams were made of carbon fiber composite, very light and very strong. A guiding principle in the design process was building a plane that was as light as possible to minimize fuel consumption and reduce running costs. Wherever possible, the team looked for lighter materials that could substitute for more conventional ones. But in one case, this got the 777 team into trouble. The design of some parts of the plane called for using a new metal alloy called aluminum lithium. Aluminum lithium was to be used in a whole range of areas in the plane. It was expensive, but it was also much lighter and helped the plane meet its weight requirements. But long after the decision had been made to go with the alloy, they discovered a problem. The new metal developed small cracks when it was drilled.
Cracks are a very sensitive issue, as you can imagine in airplane design, because we go to great lengths to not only not have cracks, because cracks usually mean that the crack can propagate or get bigger. Plus we go to a lot of detail to make sure that if the crack does get started, that we have ways of stopping the crack so it doesn't grow. It's just part of our normal design process. The The issue we had with aluminum lithium is that for the applications we were using it, the cracks were okay, technically, but you could see the crack. So how would the customers feel about that? They could see the cracks. Now we'd have to say, on these parts, Mr. Airline, the cracks are okay. And they would have to figure out how to communicate that to all the people that interface with the airplane.
It was time for a decision. Already, the factory was preparing to manufacture parts with aluminum lithium. A meeting was called of all the engineers involved. Before the meeting, the halls were buzzing with rumor and comment.
They're talking about cancellation costs like $2 million for much of the applications we're talking about.
And I think on the aluminum lithium meeting, we all had both opinions in our minds at the same time. It'd sure be nice to just go ahead and get that weight in the bag and done. It would sure be nice not to give the airlines and ourselves an extra problem. So you got to be very careful not to make up your mind and let all of the different sides of the issue get out in the open, and then collectively use your strength to make the decision. So the way we try to get the best decision is to get all the pieces out on the table, see what's new, see what that means to us, can we do something about it or not, and then usually that thorough discussion leads you to the right direction.
You're going to have parts here that sooner or later is going to be discovered. Major or primary structural components like Section 12 rib stiffeners, which the airlines for 30 years or 35 years, whatever it is, when they find a crack, they figure they don't fly till it's fixed, and it's a whole. I don't know how big the crack's going to be after 5 years or 10 years, whatever it is, but you have the potential here of developing multiple numbers of parts that are going to have minute cracks in it, and to the airlines, that's not an acceptable structural configuration for the airplane.
It's acceptable if Boeing says it's acceptable.
Well, you've got a basic material characteristic you know about already. For example, you know you can't use it in sheet. You know you can't use it in plate. You know you can't use it in some kind of extrusions. 2 more just fell off for whatever reason. You know, the handwriting's on the wall. It's just something that I think you need to listen to.
Well, the data's on the wall.
The data.
Maybe I'd like to say a few words since Brian has had a chance to talk about this. The fact is now is that from a technical point of view, I would not put this back on the airplane if I had a choice, because we know more than we do now when we made the decision. On the other hand, I do remember that 280 pounds are still an extremely valuable weight saving for this airplane. And if we take this 280 pounds out, then I don't know where I'm going to get it. We've worked extremely hard to save weight, and we're going to continue to work hard to save weight. And so it's a balance.
Yeah, I think everybody here is aware of the big issues. I mean, it's going to come down to cost and weight versus economic risk.
There's the economic risk, and the worst thing is having to explain this to the airlines forever. I think that's the problem with the preferred airplane.
But it's not black and white, and and if we were 12,000 pounds ago, it'd be a different situation than we are today.
The decision to remove the aluminum lithium emerged almost by stealth, as the group moved imperceptibly from discussing what would happen if they removed the alloy to planning how they would manage without it. Mullally had achieved a genuinely unanimous decision.
We are tightly bound together.
Nobody said this would be easy, right?
Creating solutions and balancing of objectives.
The fact is, it was a good decision. There's no question about that. Again, we thought of the customer, which is what we ought to always think of in decisions of this kind. In this case, the material exhibited certain properties that we didn't think were acceptable. And it wasn't a safety issue at all, but it was a quality perception relative to those imperfections. And we decided until that material had those imperfections removed, we just didn't feel it was appropriate to put them in the aircraft, so we didn't.
The repercussions of the aluminum lithium decision were to rumble on for a long time, with particular significance for the work being done in Japan. A group of Boeing managers, led by Vice President Neil Standel, traveled to Japan to visit several companies that were making parts for the 777. The trip was a mixture of corporate relations, making the Japanese feel appreciated, and checking up on the parts that would soon be needed in Seattle if the plane was to stay on schedule.
It takes, as you well know, a lot of capacity both in people and in equipment to build an airplane. So you want to spread that, if you can, across good foundation or good suppliers. The other reason is for sale benefit, like in dealing with Japan. They buy a lot of our airplanes. They're the biggest buyer of the 747, for example. So we want to have a relationship with the Japanese.
The Japanese were manufacturing 20% of the parts for the 777. Some of these were supposed to have been made from aluminum lithium, including key components of the wings called in-spar ribs. Nippy, the company making the ribs, had scrambled to redesign their machine tools so that another metal could be used. These trips turned executives into 24-hour-a-day workaholics. Business and noodles became hopelessly intertwined. The group was thinking ahead to its visit to Nippy just 2 days away.
I have the materials for Nippy in my briefcase.
Now, when did Nippy ship the in-spar ribs?
On the 30th.
Have they arrived in Seattle?
Yes, they have.
I saw it during that. I like that.
You can eat sushi with fingers. Try it sometime, it tastes better.
I've ruined 26 neckties, and now she tells me I can eat with my fingers.
Yeah.
Bring the bottom end up and then it doesn't flap around.
It's a slurp, but let's all watch Neil slurp it.
How do you do it?
I want you to do an extraordinary. Not all those, you'll never. Wait a minute.
I bite them off.
No, you're supposed to slurp them. Oh, look at that.
Now I know why you got to be a vice president.
Yeah.
Dunkin' Dots.
Many people, including some employees, wondered why Boeing had involved the Japanese at all. Building large aircraft was one area of technology the Japanese had not yet developed. Yet here was Boeing operating on what some people called an open kimono policy. But for the 777 team, this collaboration provided access to high-quality heavy engineering and equipment. Kawasaki had constructed an entire factory just to make parts for the 777 fuselage, and part of the purpose of Standel's visit was to attend the opening ceremonies. No such occasion could be allowed to pass without a Shinto religious ceremony. This was a significant event. A priest might receive several $1,000s for a service like this, in the hope that the gods would look favorably on the machinery and ensure that it ran smoothly in the years to come. While Standel looked out of place with his Japanese colleagues, he had done his homework when it came to joining in.
Good job. Bye. Did you get your little cedar box? I'm going to take this home for my wife for an Easter gift. We don't get a chance to go shopping, so this is going to be your Easter gift. Somebody took my original one, so I went and got another one.
The next stop was a visit to see how things were going on the passenger doors. The new design methods had made it possible for all 8 doors on the plane to have many parts in common, which saved time and effort in the manufacturing process. In their relations with the Japanese companies, Boeing had to take careful note of the cultural differences between Japan and America. As Standall and his colleagues toured the various factories, they sometimes found problems that had to be dealt with as tactfully as possible. One of these became a worry.
About a month ago, we discovered a problem, brought it to their attention. They told us what they were going to do to resolve it. Things weren't happening. We met with them last week. That was one of the reasons we came over early. They showed us what they were doing, and it was unacceptable. We expressed our concerns to them, told them what was wrong. We had our people work with them on again, off again during the week, and we were not getting anywhere on resolving this. So we asked for a meeting with the general manager, and that meeting could have been very difficult. And as it was, and I couldn't sleep because I was worried about it. Mr. Blakely was worried about it. Neither one of us slept well. And we went in the meeting, had a good open discussion, and so we were relieved. But it could have been, what next if we, where do we go next if we fail here? So we were worried. And I think that, that speaks of the relationship we want to have with them. If we were whimsical and didn't care, we would have gone to bed and gone to sleep. But we care.
The following morning, the group visited Nippy in Yokohama. While the bus was on its way to the plant, the workers were already in the middle of their compulsory morning exercises, surrounded by the 777 in-spar ribs the company was building. Standall's visit to Nippy was partly to thank them for staying on schedule in spite of the changes in design and material. He presented the company with a certificate of thanks from Boeing's senior manager. As Standall and his colleagues left the factory and headed back to Seattle, they had mixed feelings. Satisfaction at seeing how well the Japanese had learned how to build airplane parts, mingled perhaps with concern about how long it would take before the Japanese would be building airplanes on their own. In Australia, things were going badly with the rudder. The much-feared stuff-up had happened. Boeing had decided on a third major design change to compensate for the rudder vibration. It was another major setback for ASTA.
We've got a lot of major tools either completed or nearly there. And this last change is probably going to affect at least 65% of our tooling program, and we've got some 600 tools. Anywhere from the large layup mandrels like you've seen to some of the big, huge assembly jigs to put the thing together. It changes a lot of it.
To soften the blow, Mike Voigtland from Boeing arrived to explain the changes in person. It was a difficult job at best, but it was made worse by the fact that Boeing's engineers were still tinkering with the design as he was flying to Australia.
We need to have a telephone conversation with Seattle to find out between the time we left and the time we got down here if there's anything that's changed. Now, the bad news is, as you all know, we don't have a lot of time left. And I looked at the schedule last night when I got in, and it tells me that we have about 5 months and 3 weeks to complete this hardware, which is a task that I would say under normal flow conditions would take about 18 months. So we have quite a challenge ahead of us here.
As the Boeing people laid out the changes, it became obvious to ASTA that their worst fears had been realized.
Are you going to change that rib as well?
It looks like, worst case, we get this rib, and the rib spar. That's the bad.
That is bad news.
Now, there is a new task plate up here, but we didn't quite have the details on that before I left.
When we all came back from the holidays and we thought we had a nice smooth sailing program once again from the last change, they told us, for instance, several of these parts weren't changing, absolutely not. And so we've rescheduled the program based around that particular assumption, and now, just today, we find out that some of those major tools are changing. The addition of this fifth hinge, the changing to those rear spar mandrels and whatnot, is a big impact. It's going to be an interesting one to manage in the time frame.
Are we going to live with April the 5th?
Sure.
You will. I'm sure you will.
That's a month after we asked for it.
Come on, you guys have to give me some. Man.
Yeah.
You guys are just. What'll happen is.
We're going to give you a rudder if you're lucky.
Boeing had to keep the pressure on ASTA. The delivery date for such a key part of the plane couldn't be allowed to slip, since it would jeopardize the whole 777 project. But Voetlin was clearly worried that ASTA would not be able to keep to the new and punishing schedule.
All right, what are you now saying?
Problem is, the magnitude of the workload is enormous, and the opportunity for things to go wrong is great. And that's why I say that I am maybe a little more pessimistic than what you might hear from ASTA.
Boeing has to have respect for a small company that's essentially, I don't want to say bail them out necessarily, but certainly help them out of a bind. I don't know as Boeing could get through one of these changes like this late in the game in-house on their own program.
The schedule is based on.
Back in Seattle at the regular critical issues meeting, as it was called, the team was going over the myriad problems that threatened the already tight schedule.
Probably the single biggest item that we're trying to do now is number, whatever it is, 12, panic early.
At each meeting, the team analyzed the case histories of things that had gone wrong.
We looked at the payloads, we looked at the systems, now we'll look at the structure. And I think Wolf made a good point, which we'll start to show up in these next two, and that is you miss your first commitment and then things start to go wrong. Here's an example of a fuel jettison system, find all the pieces here. When they got around to do the installation, somewhat late, there was a problem. This will not accept the vent tube.
The issue there was that the engineers had a design and they'd actually ordered the parts to build it. Yeah, it's really just a tube that comes out of the outboard end of the trailing edge, and it enables the airplane to dump the fuel should it need to return to the airport. When they came to work the installation, which involved other interfaces, then they realized that the details and assemblies that they released prior to that time had in fact an interference problem.
They discovered at the assembly stage that a piece called a nut plate interfered with the fasteners on the vent tube, exactly the sort of thing the new design techniques were supposed to prevent.
What would it tell you to do or emphasize for the future?
Ideally, you'd model in all your fasteners and the nut plates, ideally. However, secondarily, if you work to the schedule and not give up time, that there is more time to recover. Here we've had a situation where we didn't get the installation done, and so the surprise came later. And now it's so late that we're out of sequence.
There's enough detail in the definition as the installation's being built up that the engineer, if he's really paying attention to it, knows he's got a nut plate there. Maybe he's not modeling that nut plate, but if he knows he's got close interferences between parts,
He has to deal with it.
He has to deal with that.
Or he doesn't have any
and he needs to
solution.
model it in that case. So,
So our long-term hope is that every designer with his ME counterpart gets it to the place where they have an integrated solution, and only they can tell us that, because they're the only ones that know those pieces going together.
Yes. And we had to address that so that we know who's been there. There's a clearinghouse. At times I sit in meetings, and even now, I get thinking from time to time, boy, back on the 767 or back on the 737, this is what I did and it worked, and I get impatient, I want to pounce. And yet with the style we have and the team that we have, we are all in this together. We support one another. We don't pounce on one another. I can remember incidences on other programs where various functions would just be at each other. The parts weren't here and the manufacturing guy needed them, or the design wasn't done so the planners could do it. And they'd be across the table at each other just talking very loud. And I've seen that over many times in my career. And when you sit and look at the style we use, if he's got a problem, that's my problem. So let's go work it.
What do y'all think of Jerry's work?
How about his team?
Huh?
Midway in the year, there was a meeting of the whole 777 team. The only place that 10,000 people could assemble was in the factory, on the very spot where the first 777 would roll out of the building in 9 months' time. The occasion was a reminder of how patriotism and plane making went hand in hand.
How are you? Hi, how are you?
Good. Morning, Mr. President.
How are you?
Now, will you please join me in welcoming the 777 Division Vice President, General Manager, Alan Malala.
So good morning to you all. This is the 9th all-team meeting that we've had on the program, and we've come a long way together. It's been 21 months since we launched the 777 with our order from United Airlines. We only have 8 months to go before rollout. We are going to turn power on the airplane in January of next year, with a first flight of June of next year. So it's really coming together fast. Today, we thought it would be
At about the same time as the all-team meeting, there was another milestone in the life of the first 777. A whole wing was going to fly, out of the jig in which it had been assembled and across the factory floor. It was 2 weeks later than planned, but everyone hoped they could make up the time in the months ahead.
Well, you better see if they all freeze. I just raised the tape in around that. Take it down, pop it up. Let's just hang on now. Let's go down. Now we've got the half the distance down.
Before the wing could be lifted, it had to be freed from a series of fixtures on the tool, one of which was proving difficult.
They're going to be a couple minutes, aren't they?
In this high-tech factory, it was a hammer that finally did the trick.
We need to be careful that we don't hurt somebody's finger in pulling that out or damage the tool itself. So we want to be cautious as far as how we drive it out. And right now we're using a smaller drive pin, and it just freed up. That popped, and now she's done. So that's good news.
Our crescendos one after the other. This just happens to be another one subsequent to that one in January where we loaded the spar. Now the wing. Tomorrow we'll load the stub and the keel beam. So we're just one right after the other now as far as the first airplane is concerned.
This is our last locator. Let's go on back over to our positions along the wing again now. We need some people in the mid-span here. Going up! Coming up!
22 on. Okay, this SOB kicked about 4 inches north here at the top edge.
Oh, lovely.
Okay, ladies and gentlemen, we are about to begin our descent into Orlando International. Hope you all had a good flight. And yeah, we'll see you guys down on the ground.
Ladies and gentlemen, we are now descending and preparing to land. Please ensure that your cabin bag is safely stored. Make sure your window blinds are up, seats are in upright position, and your table trays are folded. Thank you.
Holy crap, chat, we've lost all our... What's going on here? Hang on, boys, something's going on. That's an error. Fuel's low? No, fuel's not low. Hang on, boys. let's pause this. I'm going to save it. See if we can recover it, guys. Recover the flight. Go. We're back. All right. Are our engines gone? What? What the hell's going on here? We've got no engines. Don't get this. Why this happens. There they go, they're spooling up now. Got power. There we go. Electric gen off. No, it's all back on. There we go, we're back, boys. Holy crap. That's one way to get down, isn't it? That's how you recover. Don't panic. Alright, we're back. Let's get our autopilot on. We're down to 22, that was quick. We need to just hold here. And let's get in touch with the radios here. Yeah, I don't know what happened there. Very odd. Sound.
Change destination to Orlando.
American 53 Heavy is cleared to Orlando Airport as filed. Squawk 5375.
American 53 Heavy cleared to Orlando Airport as filed. Squawk 5375.
Electric gen off.
To Juliet, you are 13 miles west. Descend and maintain 10,000 feet. Expect vectors visual runway 36 left approach. American 53 Heavy raise back correct. Radar contact flight level 280. Continue to Oscar Charlie Foxtrot turning and following heading 050. Descend and maintain 15,000 feet.
There's power.
Continue to Oscar Charlie Foxtrot turning and following heading 050 descent and maintain 15,000 feet. American 53 Heavy.
50.
And maintain 10,000 feet. Expect vectors. Visual runway 36 left approach to near 22 Juliet.
American 53 Heavy contact Jacksonville Center on departure on 125 decimal tree.
050.
Going to 133 decimal tree, 25 American 53 Heavy.
Let's do what they say.
Jacksonville Center American 53 Heavy is passing flight level 280 descending 15,000 feet.
American 53 Heavy Jacksonville Center continue to Oscar Charlie Foxtrot as planned. Southwest 411 contact Miami Center.
Oh, we've lost our bloody... Oh my god, this is not good. Oscar Foxtrot. Legs.
2 decimal 35 for Southwest 411.
I'm going to assume we're going to come in on, I don't know, 35 right. God. Oh, jeez. Sierra Echo.
Delta 132 and contact Miami Center on 132 decimal tree 5. Good day.
That's better. Alright. LNAV on.
132 decimal tree 5 for Delta 1321.
Electric gen off. APU. Not gonna touch anything, chat.
American 53 Heavy traffic is 11 o'clock 4 miles at flight level 2 tree 5 generic. Report them in sight.
American 53 Heavy have the traffic.
Generic 4 Foxtrot Lima traffic is 8 o'clock 3 miles at flight level 250 Boeing. Report them in sight. Generic 4 Foxtrot
Ladies and gentlemen, we are now descending and preparing to land. Please ensure that your cabin bag is safely stored. Make sure your window blinds are up, seats are in upright position and your table trays are folded. Thank you.
Southwest 15908 contact Tampa departure on 119 decimal 9er. Good day.
Decimal 9er for Southwest 15908. Jacksonville Center American 53 Heavy. Request minus 1,000 feet.
American 53 Heavy request denied.
Okay, let's hope they give us our runway. It's very hard to try and pick. Like, I always think that we're going to land kind of into the wind, but it's not always the case, and I can never tell what runway these guys are going to give us. So sometimes we get it right, sometimes we don't. We've got 63 to cruise. And then we have picked runway 35 right.
American 5-3 heavy descend and maintain 9,000 feet.
Descend and maintain 9,000 feet. American 5-3 heavy.
Give us a vector. That's probably going to help. Let's grab a vector off them.
Jacksonville Center, American 5-3 heavy. Requesting vector to next waypoint.
American 5-3 heavy, continue to Oscar Romeo Lima turning and following heading 050.
050. Shall we do it?
Continue to Oscar Romeo Lima turning and following heading 050.
Ah, no, they're taking us through the top. They want us to go to ORL. So let's find out what they're on about. I think we're coming in at the top. What are they saying? ORL we've got to find. Come on, you son of a gun. Let's load. ORL. Shall we assume they're going to send us to runways 18? One of the 18s. ORL.
Generic November 878 Papa Romeo, Jacksonville Center, continue as planned.
So yeah, I just can't pick it. Can never pick it. Can we just get the... Just get that airport up. There we go, that's what I want. ORL. Oh wait, we'll see where they take us.
Air Shuttle 6079er, contact Miami Center on 134.55. Good day.
050.
134.55, Air Shuttle 6079er.
Oh, we'll just have to trust ATC. I don't really trust them, but...
Jacksonville Center, American 5-3 heavy. Requesting vector to next waypoint.
I just wish we had the waypoint up.
Continue to Oscar Romeo Lima turning and following heading 050.
Oscar Romeo Lima. ORL. Okay, let's trust them.
Descend and maintain 10,000 feet. Expect vectors visual runway 1 right approach. United 722, contact Miami Center on 132.35. Good day.
Continue to Oscar Romeo Lima turning and following heading 050 American 5-3 heavy.
Jacksonville Center, generic November 751 Echo Delta, is at flight level 430, descending 10,000 feet. American 5-3 heavy traffic is 9 o'clock, 4 miles at 10,700 feet generic. Report them in sight. Sun Country Tree 047 traffic is 9 o'clock, 4 miles at 13,800 feet Boeing.
Can I just put it in here?
American 5-3 heavy traffic in sight.
traffic is 7 o'clock 4 miles at flight level 340 generic. Report them in sight. Sun Country 3047 contact Tampa approach on 135.5. Good day.
Where's ORL?
135.5 for Sun Country 3047.
ORL, is that it? Nope. Where's ORL, guys? ORL. Is that him? Is that it? Nope. Oh, they're sending us back up here. That's interesting.
American 53 heavy contact Orlando.
Did we?
135.3.
It's Wandu. We get way off our track. ORL Orlando. That's it. Gotta be it.
American 53 heavy Orlando approach altimeter 30.13. Continue to Oscar Romeo Lima as planned.
I have no idea. We're just gonna have to take their word for it. Runway 17L. Ah, is that where they're taking us? ORL. Look, there it is, guys. Found it. We better turn around. There's ORL. I'll go to Crappie. We need to slow down. Get ready for this landing.
American 53 heavy descend and maintain 5,000 feet.
5,000.
Descend and maintain 5,000 feet. American 53 heavy.
Busy, busy, guys. Got to keep busy. I'm gonna bring us down to 180. We still got a fair way to drop here. So let's go extreme here. 190. Why are we not dipping? Maybe we'll yank on the speed brake all the way. Okay, we're on the manual throttle. Put some flaps down. Ease up on the old speed brake. We'll go to crappie. Alright, let's get that speed brake off. We don't want a belly flop here. She likes to drag a tail here, especially if you haven't balanced her right. The old girl. So what did they say? We're going 17 left. So let's see if we can get that happening here. 17 left. ORL. No. RNAV 17L. Danya. Nah, we're gonna go in and do this ourselves here, I think. Look at this mess. Look at this mess. Let's just go direct, man. Look at this damn mess. Can't we just go to Herv? Hervey. Echo. VI. Oh, God's sake. Be the death of us, this will. VI. Go previous. Punch that in. Execute and then delete all the crap. Delete. 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 Execute.
Generic 1 Tango Charlie, you are 20 miles north.
Done.
Maintain 5,000 feet, keep speed not above 210 knots, expect ILS runway 27
Come on.
right approach via SMYRA transition. Clear to SMYRA.
She's not responding.
Feet, keep speed not above 210 knots, expect ILS runway 27 right approach via Smarado
Go on, turn, girl. That's it.
Orlando affirmed Frontier Flight 1051 is passing 9,700 feet, descending 4,000 feet.
Frontier Flight 1051 Orlando, approach altimeter 30.12, continue to expedite as planned. American 53 Heavy, you are 300 feet below your assigned altitude. Climb and maintain 5,000 feet, altimeter 30.12.
Not a chance, buddy. They're just so full of it. Honestly.
Maintain 5,000 feet, American 53 Heavy.
Like, can you guys just not get it right? I'm going to 2,000. Data, they want us at 3,000 when we get to Cedo. So we need to get our ass into gear here. And we're rendering in. We haven't been here, and this is going to be a big render. This will affect our performance. Okay, let's get this off. Just taper off our vert speed a little bit. And we've almost hit our 3,000. This is good.
American 53 Heavy, please expedite your climb 5,000 feet.
Don't understand why they would do that. There's our runway, guys. I can see it. Cooking with gas.
One Tango Charlie, descend and maintain 2,000 feet. Descend and maintain 2,000 feet, generic 1 Tango Charlie. Frontier Flight 1051, please expedite your climb 4,000 feet. Generic 1 Tango Charlie, descend and maintain 1,600 feet.
On 1095. Let's see if we can quickly plug in. We are plugged in. This is great. See if this works. Let's see if we can get away with it. We're on low.
1,600 feet, generic 1 Tango Charlie. American 53 Heavy, please expedite
See if we can
your climb
catch it.
5,000 feet.
Capture the ILS. Why is...
Tango Charlie, you are 9 miles northeast of Orlando. Contact tower on 120.3 when inbound on the approach.
Speed brake, auto brake on full. Shit, I forgot to put those on. I'll get a slap on the wrist for that.
Runway 36 right approach via tramp transition. Clear to tramp. Frontier Flight 1051, please expedite your climb 4,000 feet.
Maintain present heading and altitude. Expect ILS runway 36 right approach via tramp transition. Clear to tramp, American 53 Heavy.
You're telling us to go to 36 right? What?
Tower on 120.3, generic 1 Tango.
We're on the wrong one, guys. 36 right, for God's sake. What? Are they kidding? Are they joking, guys?
Frontier Flight 1051, please expedite your climb 4,000 feet.
They want us to go to 36 right now? That's the other side.
American 53 Heavy, please expedite your climb 5,000 feet.
Hang on, guys.
Frontier Flight 1051, descend and maintain 1,600 feet.
I really hate this heading bug, man. I loathe it.
Frontier Flight 1051, you are 6
Like,
miles
why
south
can't
of
I
Orlando.
just double click it?
Contact Orlando Tower on 118.4
I mean, are you fucking joking? Where is it? Where's my bug? Look at it. Bloody joke. They changed their mind on us. Why would they send us all the way around here? Chat. Alright, we've got to get our autopilot engaged here. This is ridiculous. Hold 3000. And they want, what? 30? Orlando. American 53. Present heading. Altitude. Expect ILS runway 36 right. I'm going to bring flaps up. We're going to pick ILS 36 right. There it is. Tramp. Enter. Let's just go to tramp. Oh my god, what a mess. Yeah, that's why they want us to go to 5,000, because you bloody screwed us around. It's so annoying. Bloody AI, dumb as they come. Let's go straight to tramp. Legs. T. And let's get our auto throttle going here. AMP.
American 53 Heavy, please expedite your climb 5,000 feet.
What a mess. There we go. We're back on track, guys. But what we'll do is we'll move our bug this way. I should have just selected another approach. We won't upset the apple cart. This is good because I want to load this map in anyway, so doing a roundy like this is actually going to help us. Hey Adam, how are you, mate? Welcome. Thanks for the sub, dude. Appreciate it. Sorry, I was in the middle of middle of a disaster here, so I haven't been able to keep my eyes on the chat, guys. Apologies if you're still there. So let's check our radio. ILS 36 right, 11070. So it looks like we're set there. Let me double check that that frequency is the same. 11070. Beautiful. Just in time for a gnarly landing, guys. I've still got to fly up to New York tonight. It's the last thing we do. Excuse me.
maintain 4,000 feet American 5-3 heavy.
American 5-3 heavy descent and maintain 3,000 feet.
Thank you.
Descend and maintain
Now we're cooking.
3,000 feet American 5-3 heavy.
Now we're cooking. Flaps down. Let's get these flaps down. I'm going back to manual throttle. Let's do that again, shall we, chat? Love the landings, guys. It's where all the work, hard work comes into it. All your knowledge, skills. Especially when things go wrong. I mean, what a trip. We've lost our engines. Okay, we should be turning. Here we are in Orlando. I'm actually going to Orlando in about 5-6 weeks. Come on, pan out now. There's our runways. I can see them from here. Okay, let's get approach mode on, drop our legs. She's a pretty flat old bloody city, isn't it, Orlando? Nothing flash here. Pretty boring geographically. Okay, flaps 20. Prepare to land, crew.
American 5-3 heavy, you are 12 miles south of Orlando. Contact Orlando Tower on 124 decimal tree when inbound.
See if our ILS will work.
Orlando Tower, American 5-3, heavy 11 miles, south inbound ILS runway 36 right approach.
American 5-3 heavy, Orlando Tower. Altimeter tree 0 decimal 14 wind tree 40 at 19er. Cleared ILS runway 36
Ooh,
right.
flaps down.
Cleared ILS runway 36 right approach, American 5-3 heavy.
All right, who's this bozo flying around in front of us? Alright, ILS is not working, so we're going in manual. AP's off. What's this idiot doing? I bet he's in a bloody F-18. Kids, mate. It's the kids. Ah, looks bigger than an F-18. Oh, he's in an A. Is he gonna crash? I bet the cowboy comes in underneath us.
Caution the generic landing runway 36 left. Clear to land runway 36 right.
Thank you. I am not going to bail from this landing. If they tell me to bail because some idiot... I can see someone on the runway, and that means they're going to tell us to go around, and I'm not. We got shit to do.
Clear to land runway 36 right American, 53 heavy.
Clear to land runway 35 right, number 2 American 2058.
Wind 330 at 8 knots.
Don't do it, mate. He's going to pull out in front of us. Look, I can see him doing it. He's on the grass. Bloody amateur. Look. They're going to go around because this fool doesn't know how to fly.
Landing time logged.
Ladies and gentlemen, please keep your seatbelts on until we reach the gate. On behalf of the entire crew, we would like to wish you a Merry Christmas and a Happy New Year. Thank you for choosing to fly with us today.
Laggy, laggy.
American 53 heavy contact ground on 121 decimal 8.
121 decimal 8 American, 53 heavy.
Let's just load in here, guys.
Engine on time logged. Flight is finished. It has been monitored by OnAir.
Come on, give us a bloody park, will ya?
Orlando ground, American 53 heavy, request taxi to parking.
American 53 heavy taxi to general aviation
parking by taxiway Bravo 6 Charlie Bravo 7 Bravo Bravo 6 cross runway 36 right Yankee Zulu Juliet cross runway 18 right Juliet Alpha.
Let's just load it in, guys. Load in. This is one of our HBOs, so
Bravo 6 cross runway 36 right Yankee Zulu Juliet cross runway 18 right Juliet Alpha American 53 heavy.
thanks so much, guys, for flying with us tonight. Appreciate it. It was a pretty good flight until the end there. We had a few dramas. Where are they taking us now, guys? Oh, they want us to go back over there.